Good morning. Today we are going to discuss about the unit 2 magnetical particle testing. In this magnetical particle testing, so the following topics will be covered in this unit. Number 1, what is meant by magnetic particle testing? The principles of magnetic particle testing and the applications of magnetic particle testing, and also the applications and what are all the magnetization methods. What are all the magnetization methods are available in this testing of magnetic particle testing inspection? And so what are all the magnetic particles are used for this inspection of MPT method? It will be shortly denoted the MPT. That means magnetic, the M defined magnetic, the P defined particle, the T English letter it will be define the testing, magnet particle testing. So the two types of magnetical particle testings are available. One is dry particle technique and another one is wet particle fluorescent technique. And also the unit will be covered on demagnetization. What is meant by magnetization and what is meant by demagnetization? And so what are all the advantages and limitation of magnetic flux and magnetic particle testings? The next topic is what is the principle of magnetic flux leakage testing, and so what are all the instruments have to use it for testing the magnetic inspection method, and so what are all the applications in the MPT method. So where the magnetic particle testing method is used, and what is meant by electromagnetic induction technique, and the definition and the principles of electromagnetic induction method, and also what are all the instruments have to use it for this electromagnetic induction method and applications of the electromagnetic induction. The last one topic is eddy current testing. So definition and the principles of eddy current testing, and where the eddy current testing inspection is used, and what are all the advantages of eddy current testings, and what is the applications of eddy current testings. So these are all the topics I have to covered in this electromagnetic inductions. So first one is magnetic particle inspection. That means the testing is also called as an inspection. So what is mean that? The definitions. Yeah, non-destructive. The magnetic particle inspection is one of the non-destructive testing. That means NDT method. That is also one of the NDT method. The non-destructive testing method used to detect the defect in the testing specimen or composite. It is a very fast and relatively easy to apply on the part of the surface which is have to check or inspect the workpiece. And the preparation of the working specimen is not a critical. It is one of the easy method. Like a liquid penetrator testing, they have to prepare the surface of the given working specimen is before testing. You have to make so much of preparations. In this MPT method, there is no need for critical preparation of the working specimen. This MPT method is most widely utilized for non-destructive testing methods. It's one of the MPT method, and also this MPT method is most widely used in this NDT method. In this testing, the magnetic field have used for testing the working specimen. Also, the small magnetic particles is utilized for this testing method. That means the small iron particles that will be detect the flaws which is have on the component the magnetic particle. That means the iron particle will be located where the defect will be occurs. The only requirement from an inspectability standard point is that component being inspected must be made of ferromagnetic material. So in this MPI method, the ferromagnetic material, that means the metal having an ferromagnet. That type of material only we have to inspect by using the magnetic particle testing. Like as a iron, nickel, cobalt, or some other alloys. The ferromagnetic materials are material that can be magnetized to a level that will allow the inspection to be effective. So the method is used to inspect a variety of products from such as castings, forging, weldments. Many different industries use some example of the industries that use magnetic particle inspection are the structural steel. The MDT method is most widely utilized for the automobile manufacturing companies and also the research center for the space, that means ISRO for India, Indian Space Research Organization in India, and also overall country they have utilized as space research as well as this automobile industries is maximum utilized for this PA method because most of the component in the automobile for structural design you have to use it as a ferromagnetic material. And the petrochemical industry as well as the electrical power producing industries. Most of the hydro power plant, hydroelectric power plant, they have utilized for the turbines. The turbine blades are made up of some composite that will be used as ferromagnetic material. Any defect in the presence of the turbine blade, turbine shaft, and also the accessories in the turbine you have used as a magnetical particle inspection of the entity method. And also this MPA is utilized for underwater inspection is another area where the magnetic particle inspection may be used to test such things as offshore structure and underwater pipelines. Because in the under the surface of the water, some other eddy current method or liquid penetrant testing and also some other entity method is not able to use in underwater surface. In the magnetic particle inspection, we can use it as any type of environment. So the MPA method is used for the underwater pipelines and then underwater and offshore structure of the. That is one of the major advantages in the magnetic particle inspection. So the basic principle. The next we go to discuss about the basic principles of magnetic particle inspection. So what is the basic principle? Here, the theory of magnetic particle inspection, it is a relatively simple concept. It can be considered as a combination of the two non-destructive testing methods. One is magnetic flux leakage testing and another one is visual inspection. For example, you have to consider your bar magnet, one of the bar magnet. It has a magnetic field in and around the magnet. We can't able to see the magnetic field of the bar magnet, but it will be available in the surrounding of the magnetic bar. Any place that a magnetic line of force exit or enter the magnetic is called a polarity. That means pole, the north pole and south pole. A pole where a magnetic line of force exits the magnet is called a north pole, and a pole where a line of force enters the magnet is called a south pole. So if a natural magnet, it will be must have on two polarity, two poles. That means north pole and south pole. The magnetic principle, the law of magnetic principle, the opposite pole will be attracted to each other, and the same pole will be repulsed to each other. So that is the basic principle of magnet. The next is the interaction between the material with an external magnetic field. When a material is placed with a magnetic field, the magnetic force of the material's electrons will be affected. This effect is known as the Faraday's law of magnetic induction. So we can call this on magnetic field induction. The magnetic field will be induced in the surrounding of magnetic bar depending upon the electron and the orbitals. However, if the material can be react quite differently to the presence of external magnetic field, this reaction is dependent on a number of factors depending upon the atomic and molecular structure of the material. If an external magnetic field will be present in the working specimen, that means the testing specimen, the magnetic particle will be react depending upon the external magnetic field. That will be indicated here. If the magnetic moment associated with the atoms have three origins. So already we discussed about the what is meant by orbital. The electron will be located among the orbital and the suborbital. The main orbital is noted, noted as a letter of A, L, M, and N. The suborbital is S, D, D, F, S, P, D, F. So these are the electron orbital motion. The change in orbital motion caused by an external magnetic field and the spin of the electrons. Diamagnetic and paramagnetic and ferromagnetic material. So the following the principle and the definitions are the following. Diamagnetic, the definitions. The diamagnetic metals. The metal have a negative and very weak susceptibility to magnetic field is called as an diamagnetic field. That is, the diamagnetic material are slightly repelled by a magnetic field and the material does not retain the magnetic property when the external field is removed. If we go to placed nearer to this type of diamagnetic metals, the metal will be acting like as a magnet, slightly acting like as a magnet, but if we have to remove the permanent magnet in the presence of the diamagnet metal, the diamagnet metal does not retain the magnetic field after removing the permanent magnet. So that is the property of diamagnetic metal. The second one is paramagnetic metal. It has a small and positive susceptibility to magnetic field because not like a diamagnetic metal, the paramagnet it will be retain the magnet property after removing the permanent magnet in the presence of these type of metals. Have slightly maintained small and positive susceptibility. These materials are slightly attracted by a magnetic field and the material does not retain the magnet properties when the external field is removed. So, not a ferromagnet material, the paramagnet material does not retain the magnet property when the external field is removed. The small and positive only the magnetic field susceptibility. That is like as a diamagnet, but it will be slightly different from the ferromagnet material. The next one is ferromagnetic material. Large and positive susceptibility to an external magnetic field. These type of material exhibit a strong and attraction to the magnetic field and are able to retain their magnetic property after the external field has been removed. That means if it is a permanent magnet will be present on this type of ferromagnet material. It will be acting like as a magnetic material property and it will be highly positive and highly positive susceptibility because that will be gain of magnetic property and also hold the magnetic property with the internal large and positive susceptibility in the magnetic field. So these type of ferromagnetic material retain their magnetic property after the external magnetic field. That means the permanent magnet will be removed in the presence of this type of material. So that is the difference between three types. One is diamagnetic metals, the second one is paramagnetic metal, the last one is ferromagnetic. So these are all the different types of metal it will be utilized for magnetic particle inspection. We have to mostly use it for these ferromagnetic materials only. The next slide we have briefly discussed about on the ferromagnetic material. The ferromagnetic material become magnetized when the magnetic domain within the materials are aligned. This can be done by placing the material in a strong external magnetic field or by passes electrical current through the metal. Some or all of the domain can become aligned. The more domains that are aligned, the stronger the magnetic field in the material. When all of the domain are aligned, the material is said to be magnetically saturated. When a material is magnetically saturated, no additional amount of external magnetization force will cause an increase in its internal level of magnetization. See one of the related video for this. I have to present one of the video of magnetic particle testing. See the video. The video is not clearly viewed, so you have to continue the PowerPoint slide. The ferromagnetic material become magnetized. When a material is magnetically saturated, no additional amount of external magnetization force will cause an increase in its internal level of magnetization. See the picture view. So before magnetized, after magnetized. So the magnetized material, it will be getting on directional control. The way of field will be controlled by an electromagnetic field. The force will be attracted towards the direction of towards left to right. It will be going on towards. Here we go to see the general properties of magnetic lines of force. The magnetic lines. Here the picture shown the defect or flaws in the magnetic field. Previously, as we discussed previously, a magnetic field is a change in energy within a volume of the space. The magnetic field surrounding a bar magnet can be seen in the magnetograph below. A magnetograph can be created by placing a piece of paper over a magnet and sprinkling the paper with iron fillings. The particles align themselves with the line of magnetic force produced by the magnet. The magnetic lines of force show where the magnetic field exits the material at one pole and re-enters the material at another pole along the length of the magnet. See the video picture. The magnetic field, the line of magnet will be there is no deviation in one of the line curve with another line curve. Each of the line curve have definite shape and size. The magnetic line of force show where the magnetic field exits the material at one pole and re-enter the material at another pole along the length of the magnet. It should be noted that the magnetic lines of force exist in three dimensions but are only seen in two dimensions in the image. See there, the path of the electromagnetic field least resistance between the opposite magnetic poles. If it is never crossed with one of the line curve with another line magnetic path. They have all of the magnetic parts have same strength. There is no various types of strengths are allowed. Okay. Their density decrease when they move from an area of higher permeability to an area of lower permeability. Their density decrease with the increasing distance from the poles. The density decrease with the increasing distance from the poles. Flow from the south pole to the north pole within the material and north pole to the south pole in the air. So that is the general property of the magnetic line of force. For example, if a magnetic bar is having damage or broken in the center of its length, the two complete bar magnet with magnetic poles on each end of each piece will result if the magnet is just cracked but not broken completely. The north and south pole will form at each edge of the track. That means it is one of the permanent magnets. They have two poles, one is north and another one is south. For some way, the magnet is cracked in the mid of the magnet, permanent magnet, in the mid, the total size that will be broken into the mid of that. If it is the magnet is broken, where the broken will be occurs, that edge will be acting like a shear south pole of opposite to the north pole. And the right side of the magnet broken edge will acting like a shear north pole is opposite to the south pole. That is the property, natural property of the magnet. The magnet field exits the north pole and it will be after the broken of these magnets, the polarity of magnetic path direction is the field is exit to north pole and re-enter at the south pole of broken edge. The magnetic field spread out when it re-encountered the small air gap created by the crack because the air cannot support as much magnetic field per unit volume as the magnet can. When the field spread out, it appears to leak out of the material and it will be called as on flux leakage field. Okay, it will be called as on flux leakage field. That is the NPI testing method. Here, one of the testing specimen is in the field of magnetic material and the magnetical particle will be placed over the surface of the given testing specimen. So after the magnetic field induced in the testing specimen, the magnetic particle will be accumulated where the flaw, that means defect, will be occur on the surface of the given testing specimen. If iron particles are sprinkled on the cracked magnet, the particle will be attracted to and cluster not only at the poles at the end of the magnet, but also at the poles at the edge of the crack. This cluster of particles is much easier to see than the actual crack and this the basis for magnetic particle inspection. The definition of the magnetic particle inspection and flux. The magnetic flux line close to the surface of ferromagnetic material tends to follow the surface profile of the material, discontinuous of the material, perpendicular to the flux lines, cause changing of the magnetic flux lines. That is the flux leakage. The leakage field can attract other ferromagnetic particles. See, if the defect will be uh, below the surface of the given testing specimen, that means somewhat it will be minimum to the depth of the top surface to the defect. We can able to inspect by using the magnetic particle testing. The magnetic particle form a ridge many times wider than the crack itself, thus making otherwise the immutable crack or have to easy visible. If it is the crack is just below the surface, can also be revealed. The magnetic particles form a ride many times wider than the crack. Here, so much of the pictures, the pipe crack and also the soft crack and also the solid square shaped or rectangle shaped specimen. The NPI is not sensitive to shallow and smooth surface defects. The effectiveness of NPI depends strongly on the orientation of the crack related to the flux lines. See there, it is the contact plate, the stationary bench unit that related to the magnetic field. The electric current will be passed through the pipeline. If it is like it will be a permanent magnet acting as a electromagnet. Here the testing specimen, they have some defect or flaws in this pipe and plate. The transverse crack will not be detected, will not be detected by using the magnetic particle. If it is irregular crack may be indicated, and the crack under the 45 degree is also be indicated by this magnetic particle inspection. Here, the longitudinal crack will also show. The transverse crack will not be able to show by using the MPA inspection. The current will be passed through this shaft. Okay. The procedure of magnetical particle inspection. So before making a testing or inspection of the given specimen, we have to clean the surface of the testing specimen. That is the first procedure for testing. The preparation of the testing specimen. That is the clean. The second one is if already the particle, the testing specimen have anyhow type of any other type of magnetization is already in there, we have to demagnetize and they have negatively zero, that means neutral of magnet prepared by this demagnetization method. The third one is contrast dyes. Example, white paint for dark particles. And another one is the next process of testing specimen is we have to magnetize the given object or testing specimen. The first one is cleaning. So some of the surface having an oil or grease or some other. corrosion will be occur. So we have to clean the top surface and the given testing measurement. And the second one is demagnetization. The third one is contrast dyes. Then we have to magnetize the given testing specimen, and we have to add the magnetic particle on the surface of those testing specimen have to inspect. And another one is the illumination during the inspection. Example, ultraviolet lamp. Have to easily check by using the human eye, the naked eye. So we have to use it as UV lamp for inspecting the defect and the testing specimen. The another one is interpretation. The another one is interpretation. And another one is demagnetization. Have to prevent the accumulation of ion particles or influence to sensitive instruments. So after inspection is completed, we have to remove the excess amount of ion particle. It will be accumulated on the surface. So we have to apply and will be checked by inspection and after remove that magnetic particle. So magnetizing the object. There are variety of methods and can be used to establish a magnetic field in a component for evaluating using the magnetic particle inspection. It is common to classify the magnetization method as either direct or indirect. The direct magnetization, the current is passed directly through the component. The first one is the current is directly passed through the component. Clamping the component between two electrical contacts in a special piece of equipment. And the hand electrodes you have to use it for this testing method also. You have to hand electrode to check the magnetization. The magnetization by magnetizing the given testing specimen by using the handheld electron. Using a clamp or probe which are attached or placed in contact with the component. There are several ways that direct magnetization is commonly accomplished. One of the way is clamping the component between two electrical contacts in a special piece of equipment. The current is passed through the component and a circular magnetic field is established in and around the component. When the magnetization current is stopped, a residual magnetic field will remain with the component. The strength of the induced magnetic field. So, by electrical current passed through these electrical current carrying conductor, that electrical current induced the magnetic field of the given testing specimen. It is known as electromagnetic induction. The strength of the induced magnetic field is proportional to the amount of current which have to pass through the testing component. That is the one of the techniques for making magnetic field in the testing specimen. The second technique involves using a clamp or probe which can be placed on the contact of which of the specimen you have to test it. By using this probe, the current is injected into the component as it flows from the contact. The current set up a circular magnetic field around the path of current. Okay, so that is the two types. The another one is indirect magnetization. The first one is direct magnetization. The current is directly passed through the where the specimen have to test it. The second one is indirect magnetization. The current carrying conductor, that means the electromagnetic field created clamp will be placed on the testing specimen which is have to test it. The use of permanent magnet is low cost method of establishing the magnetic field. The picture shows the permanent magnet. There is no need of electrical current. It will be induce the electromagnetic field where the defect testing specimen. In this method is low cost. However, the use of limited due to the lack of control of the field strength and the difficulty of placing and removing the permanent strong magnet from the component. So that is one of the drawbacks in the permanent magnet. Another one is electromagnet. The electromagnet is already we discussed once again. The electromagnet the electromagnet in the form of an adjustable horseshoe magnet, like as a horse. So it will be called as an horseshoe magnet. It will be called as an yoke. The another name of this type of electromagnet called as an yoke. These electromagnets eliminate the problem associated with the permanent magnet and that are used to extensively for industry. Maximum it will be utilized for industry. The electromagnet only exhibit a magnetic flux when electrical current flowing around the soft iron core. The soft iron core. When the magnet is placed on the component, a magnet field is established between the north and the south pole of the magnet. Another way of indirectly inducing magnetic field in a material is by using the magnetic field of a current carrying conductor. A circular magnetic field can be established in the cylindrical component by using a central conductor. Typically, one or more cylindrical components are hanging from a solid copper bar running through the inside diameter. If the current is passed through the copper bar, finally getting the result of circular magnetic field, established a magnetic field with the test component. Here we have to use as permanent magnet, electromagnet, and coil shot. The coil shot, the coil have electromagnet. It will be induced the magnetic property on the central shaft. They have accumulated the where the defect, the magnetic property is there. The use of coil and solenoid in the third method of indirect magnetization. The coil and short method is indirect method. When the length of a component is several times larger than its diameter, a longitudinal magnetic field can be established in the component. The component is placed longitudinally in the concentrated magnetic field that fill the center of a coil or solenoid. This magnetization technique is often referred as a coil shot method. Okay. So that is the indirect method of magnetization. That is one of the NDT method. In this method, we have to check by the ferromagnetic material only. Here, the longitudinal magnetization and the circumferential magnetization. Here, the circumferential magnetic field distribution. A non-magnetic material carrying direct current. A solid conductor of a magnetic material carrying direct current. And either here you have to use the as AC current or DC current or pulsed DC that current can be used. So demagnetization. We are testing the working specimen by using the magnetization method. We have to demagnetize the testing specimen. After conducting a magnetical particle inspection, it is usually necessary to magnetize, demagnetize the component and remnant magnetic field can. It will be affect machining by causing cutting to a component because if the material have magnetization method after the machining process have done by using this type of material after testing, if it is remain in the magnet property under testing specimen, it will be affect the machining properties because the component have contact to each other. The time of contact, if the material have magnetic property, they will be sticking together. So it is a major problem for machining. So the demagnetization is very important for after the MPA testing or MPA inspection method. So another one is they interfere with the electronic equipment such as compass. If it is the testing material have to used for the applications of electronic components, that is also affect the magnetic property in these applications of the particular equipment or component. And we can create a condition known as arc blow in the welding process. The arc blow may cause the weld arc to wonder or filler metal to be repelled from the welding. Suppose we go to joining the material after the testing, that will be affect the welding process, and also it will be affect the abrasive particles to cling to bearing or spraying the surface and increase the wear. So we have must demagnetization after the NPA inspection is completed. So why do we need for this demagnetization? That is the reason for that. And magnetic particle. So we have to use as particle as the medium of NPA testing. So what are all the particles have to use in pulverized iron oxide? The chemical equation for this is Fe3O4. That is iron oxide. If it is in a small particles, so it will be called as pulverized iron oxide. Carbonyl iron powder can be utilized for this type of MPA inspection. And also we have to highlight it as a fluorescent material. We have colored or even fluorescent magnetic powder can be used for increase the visibility of MPA inspection. Suppose the magnetical particle accumulated on the surface where the defect will be occurred, but we can't able to see clearly. So here we got to use it as fluorescent magnetic powder. It can be used for dry or suspended in liquid. It may be used for the dry powder or it will be suspended in the liquid particle. In the particle that are used for magnetic particle inspection are a key ingredient as they form indications that alert the inspector to defect. The particles metals are used to have high magnetic permeability and low retentivity. The high magnetic permeability is important because it makes the particle attract easily to small magnetic leakage field from these discontinuities, such as flaws. Low retentivity is important because the particles themselves never become strongly magnetized, so they do not stick to each other or surface of the particle. Dry magnetic particles can typically purchased in or red color or black or gray color or yellow color. The fine particle around in the size of 50 mm and the smaller diameter and more than 20 times lighter than the coarse particle. The coarse particle remained around 150 mm. Wet magnetic particles also supplied in a wet suspensions such as water or oil. The wet magnetic particle testing method is generally more sensitive than the dry particle method because the suspensions provide the particle more mobility and it will be made possible to the small particle since the dust and the adherence to surface contaminants is reduced or eliminated. The wet method magnetic particle product differ from the dry powder particle in a number of ways. So one of the way that both visible and fluorescent particles are available. The most non-fluorescent particles are ferromagnetic ion oxide, which are either black or brown in color. The fluorescent particles are coated with pigment that fluorescent when the exposed in ultraviolet light. The particles used in the wet method are smaller in size than those used in dry method for reason mentioned above. So that is the reason for the use as a magnetic particle of NDT method. And they have follow some standards for MPA procedure. The one is British standard, that is DSM 35. It will be used for these aerospace series magnetic particle flaw detection of material and components. BS 4397, the method for magnetic particle testing of wells, ASTM standard. It is American standard for testing of material, ASTME 709 and 80. This is standard practice for magnetic particle examination. And the another standard is ASTME 125. The standard reference photograph for magnetic particle and porous casting. Advantages of NTU. One of the most dependable and sensitive method is our surface defect. It is the fast and simple and also that is inexpensive, direct visible indications on the surface. It is unaffected by possible deposits, example oil, grease, or other metal chips in the cracks.